Hey everyone, we are now on chapter 11, section 1, which should be one of the easiest of the entire chapter and even kind of the whole year, okay? So we have to start our parallelogram, and what I want us to write for base of a parallelogram is that it can be any side of a parallelogram. So most people automatically want to label the top and the bottom of a parallelogram as the bases, but technically speaking, we can label these two, the left and the right side, as bases as well. But if you do that, that means your height has to be perpendicular with whatever sides you choose as your bases, okay? So for this specific instance, I will use the top and bottom, but just know that we can do it the other way as well. So as I said, the height of a parallelogram is going to be the perpendicular distance between any two parallel bases. And again, here I have a perpendicular line drawn. That could be my height, but more often than not, you're going to have it drawn here like this. So that way you have a little right triangle formed, or again over here. That's typically where your height's going to be drawn. And for our area, we should know this by now, but our area is just going to be that base times height. Now, our area addition postulate is saying that the area of a region is the sum of the areas of its non-overlapping parts. So basically, all that's saying is if we consider triangle ABE, if we're looking at that one's area, plus our, let's look, I'll put it in orange here. If we're looking at our trapezoid here, plus our trapezoid, let's say BCDE, those two together are going to equal our parallelogram, ABCD. Just talking area-wise, okay? So that's not really any new information, but technically now you have a name for it. So going down here to our examples, we're going to do the first two here together. So to start, we have find the perimeter and area of the parallelograms below. So looking here at our first parallelogram, since we see that AD is 32, that means we definitely know that BC is going to be 32. And then since we see that AB is 20, that means DC is also going to be 20. So for our perimeter, that's going to be super simple. We just got to add those all up. We see we have two side lengths of 32, and we have two side lengths of 20. So if we go ahead and simplify that out, we get 64 plus 40, which is 104 inches. And again, make sure you actually have that, your units, the inches. So for the area now, we need to make sure that we have our height given to us. So looking here, if we look right here, we have a right triangle. And since we know that DC is 20, and we see that we have our EC given to us, our height, to find that, all we need to do is use Pythag. So we'll have h squared plus 12 squared is going to equal our hypotenuse squared. So again, if we go ahead and simplify that out, we should get h squared is equal to 400 minus 144, which is, let's see here, 256. So I'm jumping a few steps. And then our h, if we take the square root, we should get 16. So for our final answer of finding the area, all we have to do is our base times height. So in this case, again, remember your base is perpendicular to your height. So our base in this case is going to be our 32. Okay, so 32 times our height, which we just found is 16. And our final answer, 32 times 16, is 512. And then again, make sure you have your units, inches squared. Now, moving down here for part B, it's a little bit different because now we're dealing with an angle in our right triangle when we need to find our height, okay? So first, let's go ahead and find our perimeter because that one's going to be super simple. We already have our bases given to us, so that's going to be 2 times 12. Plus our other side length, so 2 times 9, which gives us 24 plus 18, and that is 42. And then make sure, again, you have your, your units, so 42 centimeters. Now for our height, like I said, we're going to be dealing with a right triangle and a angle given to us. So remember, we can see that this is clearly a 45, 45, 90 triangle. So we can use our rules, or what we can also do is just use our sign. So clearly, since AB is 9, that means DC over here is also going to be 9. So if we wanted to find H, looking at angle C, we have our opposite over our hypotenuse. So remember, opposite over hypotenuse, that's when we use our sign. So we're going to have sine of 45 is going to be equal to our H over our hypotenuse, which in this case is 9. And again, to solve for H, we're just going to multiply both sides by 9. So 9 times the sine of 45 is going to be our H. And if you go ahead and enter that in your calculator, make sure you're in the degree mode. And again, if you enter this in your calculator and you don't get this answer, 6.364, send me a message and I'll try to come up with a video or something or to walk you through how to put your calculator in the right form. So we have our height here, and then for our area, we already have our base given to us. Again, remember it's perpendicular to that height. So we have our base is going to be 12. Our height we just found is 6.364. And if we go ahead and multiply that out, we should get 76.368 centimeters. Okay. So I'm going to suggest you guys do that next one on your own and then check your answer with the key. For this next one, we have the area of congruence postulate, which is really common sense. You guys should already know this, but now you have an official name to it. But basically all it's saying is if two figures are congruent, then their areas are equal, okay? Now, moving on down here to numbers 2 and 3, these will be the last two we'll do together in this video, and you guys will do 4, 5, and 6 on your own. Oh, and my little note here, 5 and 6 should take you barely 1 minute to complete, okay? But number 2 here, we have find the area and perimeter of the parallelogram. So again, they went ahead and wrote the height outside of the parallelogram, which is more than fine. But if you want to, you can always draw it inside the parallelogram too, okay? So to start, we're gonna do, let's find our what's it called? Our side lengths of our parallelogram. So EF and HG here. So looking at our right triangle first, right here, okay? We have our 33 degrees, we have our opposite of that 33 degrees, and we're looking for that EF, our hypotenuse. So again, opposite over hypotenuse, that's going to be using sine. So we have sine of 33 is going to equal our opposite, which is that 20, over our hypotenuse, which is, we'll just label it as EF. That's what we're looking for. So remember, to solve for our EF, all we want to do is do 20 divided by sine of 33. Okay, and if we do that correctly, we should get 36.723 meters, I guess, technically. Okay, so now that we have our missing side lengths, our perimeter is going to be super easy to find. We're going to do 2 times our 16, which are our bases, plus 2 times our other side lengths, which we just found to be that 36.723. And for that, we should get 32 plus 73.446, which altogether gives us 105.446 meters. Okay. And for our height then, or not our height, I'm sorry, our area, we already have our height, we have our base, so that's going to be super simple, and we're just going to do our base times height, which is 16 times 20, and we get 320 meters squared. All right, and for our last one we're doing together here, we have, you need to buy enough boards to make the frame of a triangular sandbox and enough sand to fill it. So if one board is 3 feet long and one bag of sand fills 9 square feet of the sandbox, how many boards and bags do you need to buy? So to start off, I'm going to go ahead and do find the perimeter, okay? So the reason I'm going to start with finding the perimeter is because we need to know how many boards to buy. So if I know how much feet it is going to take to make the entire sandbox, I can figure out how many boards that are 3 feet long I need. So for our perimeter, we have 12 feet plus 7.5 plus 16. So altogether, that's going to give us 35.5 feet or 35.5 feet needed to build that triangular sandbox. So since we know that each board is 3 feet long, to find out how many boards, I'm just going to do that 35.5 that we just found and divide by our 3 feet. So when we do that, we should get 11.83, which again, since we can only buy whole boards, or we want to buy enough boards, we're going to round that up to 12, because if I were to only buy 11 boards, then I wouldn't have enough. Okay, so assuming that we can only buy a set amount of boards and not a fraction of them, we would say 12 boards. So for our area now, we know that 1 bag of sand is filling 9 square feet. So I want to find my area of this triangle. And again, for a triangle, that's just going to be half times my base times height. So in this case, my height is 9, and then which side is perpendicular to my height? That's going to be my 12. So if I go ahead and do that, I get 54 feet squared. And again, I want to find out how many bags of sand I can get. So if I know I need 54 feet squared and each bag is 9 square feet, I'm going to do 54 divided by 9, and I get 6 bags of sand. All right. So again, I'm going to stop the video here. You guys are going to try 4, 5, and 6 on your own, and then make sure again you're looking at the homework I posted on Google Classroom rather than your old syllabus. Okay, please let me know if you have any questions.